going to solve triangles applying the law of cosines. The law of cosines does not have the confusion that we could possibly have with law of sines. Either it makes a triangle or it doesn't. And so if it doesn't, your answer will look very strange and it'll be obvious to you. If it does, then there'll only be one answer. Okay? We've got the rule written down 3 different ways, but if you'll notice, they all have the same pattern. It's 2 sides squared. Whoops. Just undo that. It's 2 sides squared minus 2 times the product of those 2 sides times the cosine of the angle opposite that side that's out front. Okay? So if I have this angle, then I can find that side. If I have angle C, then I can find that side. If I have angle B, then I can find that side. Okay? And so the key is whatever angle is over here, the side opposite that has to be what is out front. A couple notes down here. First of all, my knuckle started to drag and then it changed where I was writing. Anyway, parentheses are recommended, not required. The reason I put that in there is because people have a tendency to do this.
Wait, is that a subtraction?
Yes. People have a tendency to do this and then multiply the answer by cosine of C. And that's not the order of operations. Okay? The order of operations would say that we square, darn it, I did that again. The order of operations would say we square this, we multiply all that out, then we add these 2 and subtract that one. Okay? Order of operations. So the order of operations, if you don't make a mistake, you don't need the parentheses. But my experience is, far too many of you do that out of order. And you have a tendency to want to do all of this and then multiply the answer by the cosine of whatever that angle is. So my warning to you is not to do that. And so to help you not to do that, I always recommend that we put parentheses around that. Again, just following the rules for order of operations is not necessary. It's redundant. But it's just a reminder to say, hey, do all this before you start adding it and subtracting it to the other stuff. Okay? So be aware of that. Now also, another common mistake. People have a tendency to throw sine in there instead of cosine. Okay? So make sure that you use cosine in this rule, not sine. Yeah, I know it seems pretty obvious now, but on the test, you're going to have tangents, you're going to have cosines, you're going to have sines, you're going to have the law of sines, and you're going to have the law of cosines.
You just naturally think the first option, which is sine.
And I'm just saying, from years of doing this with you, people just like you, okay? I love those new commercials. No, I'm not really that guy, but I'm just like that guy. I'm same age, same category, and one's a professional and one's a hoodlum.
Even things with the names right in them sometimes can have different things. Like different laws. Like I can see other things.
Well, we did area. Remember the area formula for side angle side?
Yeah.
Okay, it's 1/2 A, B, sine C, right? The angle in between them. It's going to be very easy once we have all these rules, that you're gonna start to get these confused. I have to stop and think. I'm pretty good at it. I still have to stop and think, okay, which one goes in there? Okay? And when I haven't done it in a long time, sometimes I get the wrong one.
Yeah.
I have to look it up. So it's gonna be, if, I just look at it this way, if I can make that mistake occasionally, then I know you can make that mistake. So I'm cautioning you to be very careful of that. It might, you might find it very helpful, especially using these, to practice writing the rule down before you start substituting in. So you just get used to the rule, okay? I find that for me, the more I write something down, the less trouble I have remembering it, okay? So any questions on the law of cosines? Here's how we apply it. We have a triangle here. We want to find this side. It's not a right triangle. So like yesterday, I think it was this class yesterday, I said, can we just use Pythagorean theorem there to find that missing side?
No,
And
it's
I
not a
almost
right
tricked a
triangle.
couple of you into it, right?
It's not a right triangle.
It's not a right triangle. Maybe it was the other class because we're doing similar work right now. But anyway, law of cosines here. So a squared is going to equal 84 squared plus 78 squared minus 2 times 84 times 78 times cosine 102. Okay? And so A is going to equal the square root of all of that. In fact,
Crazy.
you can just do that. A is going to equal the square root of all that. And so
So I have a question, why is
if you have a graphing calculator, then you can just plug it in that way. You wouldn't even need the parentheses where I warned you.
Yeah, so why isn't that
So
the
I did
equation? Why isn't that just the equation with the square root?
Well, it is. You just have to do it.
Oh, that's,
Bree, did you have a question for me?
I think I found the answer, but I didn't spell it wrong.
Yeah. Okay.
So I got 1.5. I got.
So what do we get for an answer?
126.
It's approximately 126?
Yeah.
125.9.
Okay. Good. Make sure you do that on your calculator again. You want to make sure that you can do these on your calculator and not have trouble. If you do, then you need to let me know. So if we look at this, I think in this, I didn't write down the directions, but I think they're asking us to solve this triangle. And so A is 19, B is 24.3, and C is 21.8. Okay? If I solve for B, I can use law of cosines to do that because I have all three sides. So 24.3 squared is equal to 21.8 squared plus 19 squared minus 2 times 21.8 times 19 cosine of B. Okay? And here is where that mistake is made. You know, I said put parentheses around this. This is the situation exactly here where that mistake is made most often. And so, help me out here. Just tell me what are these numbers squared, and I'm going to simplify this. What is 24.3 squared?
590.5.
590.5? I don't want to round. 49? Okay. was looking at that 3, wondering how we got a 5, so that makes more sense. And what's 21.8 squared?
475.24.
475.24 plus 19 squared
361.
minus, what is all of this?
Something.
I got 828.4.
828.4,
Cosine.
okay? So I'm doing this without my red parentheses. I want you to see how easy it is sometimes to make this mistake. Because people are going to look at this and those 3 numbers are going to pop out at us. And so they're going to want to add and subtract those numbers and reduce. But remember, this is multiply, right? And so that means we really are supposed to be doing that first. But we can't because we don't know what cosine of B is.
So you would.
So solving an equation, we are going to add these 2 together.
Don't you multiply by the opposite, or the?
Don't you just get it by itself?
That's the idea. We want to get it by itself. So let's go ahead and add these 2 together. 590.49 equals
836.24.
836 point what?
24.
24 minus 828.4 cosine B. And so now if I subtract my 836.24 from both sides, negative what, 245?
Yeah, 175.
It's going to equal a negative 828.4 cosine B. And so now when I divide, because this is times, so to undo I divide by negative 828.4. I get cosine B equals a positive now. Yeah, you know what, let's not do that, because we're going to have to round, right? We don't want to round. So we're going to say B is equal to the inverse cosine
No,
of
that's what I was gonna say.
245.75 over 828.4. Did I accidentally or intentionally leave my negatives off? I did it intentionally because I recognized 2 negatives made a positive and no point in messing with the negatives anymore. Okay? But if by chance only one of them was negative, then you need to keep carrying your negative sign. So what is B? Now we're going to round.
72 point, well, 73, approximately 73. You're rounding up.
Okay? So this so this here is 73 degrees. So now if I want, I can apply the law of sines. Now I chose B so that I would have the longest side. Remember when we had that scenario with the longest side? We didn't run into the ambiguous situation. Okay? So I'm going to say that sine 73 over 24.3 equals sine C over 21.8. And so 21.8 sine 73 over 24.3 equals sine C. So C is going to be the inverse sine kind of getting into a mess here. And so now I'm using my law of sines because it's easier than law of cosines once I know I'm okay. 9.1. What would I do if I got a 79 here? What would I do? Say I work this out and I got 79. What would I think about that?
What about working?
Well, you already found the longest side, so it would be able to be bigger.
That's what I want to hear. I chose the longest side to begin with, so I found the biggest angle, right? So if I get an angle now that's bigger than 73, I must have a mistake somewhere. And so C was 59. Should I use law of sines again, or is there an easier way to find that third angle? Tell me how to do it.
31 plus 59
Okay. Add up the 59, 73, and subtract it from 180. What do I get?
48.
48? Now, what if I got 60 there?
You did something wrong.
Then there must have been a mistake, right? Because the shortest side should be opposite the smallest angle.
And you could check that too.
Okay?
With,
So I could make mistakes, but and still get the biggest across from the longest side and the smallest across from the shortest side. But if I make a mistake and don't get that scenario, then I know I have a mistake. Okay? So just be aware of that. All right, kind of got to be a mess here at the end. Any questions on this one? Or it has a mind of its own today. Okay?
You are
This is Hero's formula. Before we use Hero's formula, we have to understand what a semi-perimeter is. Semi-perimeter or semi-perimeter is half the perimeter. The perimeter is add up the three sides, right?
I wonder how far this.
So a semi-perimeter would be half of the sum of the three sides. Hero's formula is a great way to find the area of a triangle if you know the lengths of the three sides. Do you agree with that, Garrett? Okay, you might agree with it better if you have it written down. So here we have a triangle. And I know the three sides of this triangle. I have no idea what any of the angles are, but I know the three sides. I want to find the area of the triangle. So what's the perimeter of this triangle? What is it? Okay. And so the semi-perimeter would be 72. So hopefully you saw that's 100 and that makes 44. So 144. And so S is going to equal half of 144, which is 72. And so we go square root of 72 times. What's 72 minus 44? Right here, 72 minus 44. 28. What's 72 minus 47? 45? Oh, yeah, thanks. And 72 minus 53?
19.
So what's the area of this triangle?
978.5.
What is it?
978.5.
178.5?
900.
Oh, 900.
I agree, Brady.
What are we round up the
think
Brady?
it's
Yeah,
0.6.
wouldn't it be
Point 6.
0.6. Run out of room there. Unit squared. Okay? Easy that way, isn't it? If I have all three sides. Now, do you see how I could possibly use law of cosines to find a third side?
Sure can.
Or law of sines to find one if I knew enough of the other stuff? Okay, so I may have to apply some of the other information in order to get what I need, but once I do that, that's very easy. All right. In that case, you should 11 through 27 odds. What is that? About 8 problems.